Hello, in this video, we will give a guide and tips for chapter 27 of my Java book. Chapter 27 is on hashing. In this chapter, we will demonstrate why hash set and hash map are super efficient. The time complexity, it's order of one, the constant time for search, insertion, and deletion. So let's see hashing. Hashing is a very important, very creative technique in data structures. So what is hashing is essentially we have a table, or you call this as an array. So this is called a hash table because we use the hash function to map the key to an index. So here is the hash function and map the key to an index. So we have this concept called perfect hashing. If you get a unique hashing, so you have two different keys and you always hash it to different index. So that's good. That's called a perfect hashing. But perfect hashing doesn't really exist. It's hard to get it. So there's a lot of limitations. So we always have a collision. So collision is that if you have two different keys, they map to the same location. So that's called a collision. So what we need to do is to address what happens there's a collision and how do we deal with collision. So this is the section we look at the hash functions in the Java API and the hash code. So this is in the object class, we have the hash code method, and that returns a hash code for every object. So this is how we implemented this hash code for primitive data types in Java API, and this is the hash code for strings in Java API. And so when you have a hash code and your table size is limited, what happens to hash code is beyond the table size. So there's a compression, it's called, you compress it and to the table size. So there's a compression. So now we are going to look at this handling collisions using, there's two approaches. One is open addressing and the other one is separate chaining. So open addressing, we have those three: linear probing, quadratic probing, and double hashing. And linear probing is, so you have a collision, so what you need to look at is the next available location. So that's called linear probing. And this is the quadratic probing. So you have a collision and then you look for the next position quadratically. So that's a quadratic. Double hashing is, so when we have a collision, so what we do the next location, and we don't go to fix the linear or quadratic, we go depending on the key itself. So we do a double hashing. So this is called a double hashing. So it's double hashing. And next, we're going to look at handling collision using separate chaining. Is that you have this table and each entry, it's actually a pointer to a bucket. A bucket can be a linked list or just a list, a simple array list. So this is all these keys, when they're mapped to the same location 4, there's a collision, so they put into bucket. So like this is key 4 and key 26, they're in the same bucket. And so this is called separate chaining. And then we look at this concept of load factor and rehashing. So load factor is this to determine how full this table is. So there's a threshold. If it's too full, that's not efficient. If it's very, very sparse, then you waste a lot of space. So there's a balance here. And we set up a load factor threshold. If that threshold is exceeded, and we're going to double and the hash table size and performing a rehashing of every element in the hash table. So now we get into the implementation of the hash map. So we see how we're going to implement it ourselves. So here's the implementation of a hash set. See how we're going to implement it. All right, so that is all for this chapter 27 on hashing. Thank you for watching. Goodbye.